The varying rate of interest, that is the concept of the compound interest formula, can also be useful in calculating the population growth rate. We can also write this in the form of varying interest, like 1 plus 0.05 to the power 1, 1 plus 0.05 to the power 1, 1 plus 0.05 to the power 1, which will be 1 plus 0.05 to the power 3 only. So in business, the depreciation term is used to describe the decrease in value of an asset. The formula of compound interest can be used for the depreciation. Hello everyone, a warm welcome to one and all. This is Yashruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to learn about the compound interest formula whenever the interest rate is varying. And the another concept is depreciation. So let us take the problems related to this. Now let's see what is varying rate of interest. So here it is possible that the interest rate may vary during the period of loan or investment. Then amount of formula of compound interest will be as follows. That is, A is equal to P 1 plus I1 whole per N1, 1 plus I2 whole per N2, 1 plus I3 whole per N3. So here I1, I2, I3 etc. are the three different rate of interest for the years N1, N2, N3. For example, if you have a loan of rupees 10 lakh, so they may give you an interest rate of 5% for first 2 years, then they may change it for 12% for the next 4 years, and then may change for 6% for the rest of the years. So that means for a few set of years, they'll give a different set of rate of interest. So we are calculating such kind of problems here. Let's take an example. A person deposited 5,000 in a bank. The bank offers 6% per annum compound interest for the first 2 years, 10% for the next 4 years, 12% for the next 3 years, and 14% from 10th year onwards. How much will he get after 15 years? So that means for the first 2 years, the rate of interest is 6%. So 6% for 2 years. Next we have 10% for 4 years. So 10% for 4 years. Next we have 12% for 3 years. And 14% for the remaining number of years. So until 15 years means from 10th to 15 years, it will be 6 years. So in total, this will be 15 years. Now to calculate the formula here, we will use the varying interest formula. Amount is equal to principal 1 plus I1 whole power N1, 1 plus I2 whole power N2, 1 plus I3 whole power N3, 1 plus I4 whole power N4. So here we have 4 different rate of interest. So therefore it is a product of 4 different terms here. Now we will substitute I1, N1. We know I1 or the rate of interest which is in the decimal form. N1, N2, N3, N4 represents the number of years here. So if we substitute here, then this is equal to, the principal was 5,000. Here it is 1 plus interest is 0.06 whole to the power N1 is 2. Next we have 1 plus 0.1 whole to the power 4. Next we have 1 plus 0.12 whole to the power 3. Next we have 1 plus 0.14 whole to the power 6. So now multiplying the given terms with the number of times and simplifying this formula and simplifying this values here and taking the product of all the values, we'll get the amount as A is equal to 5,000 into, so 1 plus 0.06 means 1.06 whole square, whose value is 1.1236. Next term is 1.1 whole power 4. Multiply 1.1 4 times. Then the value is 1.4641. Similarly, the next value is 1.4049. The last value is 2.1949. So A is equal to 25,363.70 in terms of rupees. So this is the amount he will get back after 15 years with different rate of interest. Next question, a rare species of tigers were kept in an wildlife sanctuary and reared. Its population increases by 10% in the first year and 5% in the second year, but decreases by 20% in the third year. If the animals in the beginning were 500, find their number at end of the third year. So here, the varying rate of interest, that is the concept of the compound interest formula, can also be useful in calculating the population growth rate. So it may be taken this as an example. So here we are calculating the population of tigers with respect to 3 years. So similarly, it can also be used in bacteria culture, calculating the number of population in a city. So this is one of the application of compound interest. Now here, I'll take the same formula here. The first thing is we have a different rate. So let us assume this rate of interest as 10%, 5%, 20%. But whenever it is increased, the formula will be in the form of 1 plus I whole power n. But when we are taking the population growth rate as a decreasing condition, in the decreasing condition, we should use 1 minus I whole power n. Now see here, we have 3 different rates. So to calculate the total number of tigers in the end of the third year, so that is A is equal to P into 1 plus I whole power n1. Similarly, 1 plus I2 whole power n2, 1 plus I3 whole power n3. Now observe here, we have the number of tigers initially. So this is always the initial value and amount will be the final value of the population. So therefore, the principal is 500 here. Now at the first year, the rate was increased by 10%. So therefore, it is 1 plus 0.1 whole power 1. We are calculating for 1 year. And in the next percent, it is increased by 5%. So 1 plus 0.05 whole power n 1. Now in the third here, it is decreased. So here instead of plus, we will use 1 minus 0.2 whole power 1. Now, so the total number of years is 3 with the 3 different rates here. So when you multiply this, 500, 1.1, 1.05 into 0.8. So this is equal to 462. So clearly, the final population of the tigers at the end of third year was 462. So like this, the application of compound interest formula in growth rate. So we'll take few different problems of the same kind to find the growth rate here using the varying rate of interest concept of compound interest. Now, the present population of a town is 80,000. If it increases at the rate of 5% per annum, what will be its population after 3 years? So that means every year, the population is increasing by 5%. So therefore, this can be used directly with the help of compound interest formula. That is, A is equal to P into 1 plus I whole to the power n. Now, A will act as the final value of the population and P is the initial value of the population. So therefore, it is 80,000 into 1 plus 0.05 whole to the power 3. We can also write this in the form of varying interest like 1 plus 0.05 to the power 1, 1 plus 0.05 to the power 1, 1 plus 0.05 to the power 1, which will be 1 plus 0.05 to the power 3 only, because the rate of interest is common in all the 3 years. So we can directly use the general formula of compound interest. So now when you multiply this 80,000 with 1.05 whole cube, the value will be equal to 92,610. So the new population after 3 years was 92,610. Next question. The population of a town is 40,000. If the annual birth rate is 8% and death rate is 2%, calculate the population after 4 years. So here the time period is 4 and present value is 40,000. Whereas here there is a difference of birth rate and death rate here, which is called as annual growth rate. So therefore, here annual growth rate should be the difference of birth and death rate. So therefore, this is equal to 8% minus 2%, which is equal to 6%. So this implies I is equal to 6%, which is 0.06. Now I can use the formula A is equal to P into 1 plus I whole to the power n. So present population was 40,000 and the rate of interest is 0.06 for the 4 years. So which is 40,000 into 1.06 whole to the power 4. So which is equal to 50,499.0784. So when we are calculating the population, we don't need the decimals here. So we'll approximate this to 50,500. Next question. The population of a town increased by 4% in first year and diminished by 4% in the second year. If the population of the town at the end of the second year is 39,936, find the population of the town at the beginning of the year. So here clearly the final value of the population is given, but the initial value is not given. So that means my aim is to find the initial value P. So we know that A is equal to P into 1 plus I whole to the power n. But here there is two different rate where first year it is increased by 4% and the next year it is decreased by 4%. So therefore the amount to formula varies here as 1 plus I1 whole to the power n1, 1 minus I2 whole to the power n2, because in the second year it decreases by 4%. So therefore the formula becomes minus I2. Now the total population is 39,936. So we don't know P. So 1 plus I is 1 plus 0.04 whole to the power 1, 1 minus 0.04 whole to the power 1. So this is 39,936 is equal to P 1.04 into 0.96. So here we need P. So therefore P is equal to 39,936 divided by 1.04 into 0.96. So dividing this, we'll get the initial value of the population as 40,000. Next question. If the population of a town increases every year by 2% of the population at the beginning of that year, in how many years will the total increase of the population will be 40%? So the initial value of the population was 40,000. So the next concept is depreciation. So what do you mean by depreciation? Here we have all the fixed assets such as machinery, building, furniture gradually diminish their values when they get older. So in business, the depreciation term is used to describe the decrease in value of an asset. The formula of compound interest can be used for the depreciation, but since we are talking about depreciation here, the value of the asset decreases. So therefore, the formula is given as A is equal to P into 1 minus I whole power n. So instead of plus I, we will use minus sign. So minus I in the formula of compound interest denote the depreciation of the asset. So here P will be the initial value of asset, A will be the future value of asset, and I is the rate of depreciation, N is the number of years. So we can calculate the future value of an asset. That will be lesser than the initial value of an asset, because as it gets older, the value of a machinery or any asset decreases. Now let's take an example here. Samarth bought a Walkman for 1,800. If it depreciates at the rate of 15% per year, how much is it worth after 3 years? So here the formula we use is A is equal to P into 1 minus I whole power n. So we are calculating the amount after 3 years. So the principal or the initial value is 1,800 and the rate of interest is 0.15 whole to the power 3. So which is 1,800 into 0.15 11105 whole to the power q. So the final value will be 1105.425 in terms of rupees. So this is the rate of the Walkman after 3 years of depreciation. Next question. The value of a machinery depreciates every year by 20%. What would be the value of the machinery bought for 6,250 at the end of 3 years? So the initial value of the machine is given. So therefore here A is equal to the initial value is 6,250. 1 minus the rate of interest is 0.20 and number of years is 3. So this is 6250.80 whole cube. So this is equal to rupees 3,200. So this is the value of the machinery after 3 years. Next question. A machine depreciates at 10% of its value at the beginning of a year. The cost and scrap value realized at the time of the scale being 23,240 and 9,000 respectively. For how many years the machine was put to use? So here the cost and the scrap value. Scrap value is nothing but the depreciation value. So that is A and the cost value is your P. So therefore P is given as 23,240 and A is given as 9,000. So with the rate of interest R or I is equal to 10% here, that is 0.1. We need to calculate after how many years the value of the depreciation was 9,000 of a machine. Now the same formula here we'll use. A is equal to P into 1 minus I whole power n. So here I'll write 1 minus I whole power n is equal to P divided by A. Since we are calculating n, it is in the form of an index. So to remove the index, I'll apply log on both sides. Then if I apply log here, it is n into log 1 minus I. And if you apply log for a fraction or a quotient form, log m by n can be written as log m minus log n. So this will become log p minus log a. Or I can calculate n is equal to log p minus log a divided by log of 1 minus I. So now we'll put the values here. Then it is equal to n is equal to log p value 23,240. Next, log a is log of 9,000. The denominator is log of 1 minus 0.1, which is 0.9. Now, after substituting the value of log and taking the difference in the numerator, we'll get the value as minus 0.4121 whole divided by, if you take the log value of 0.9 and simplifying it, we'll get the final value as minus 0.0458. Now we can cancel this. So the final value of n will be 8.99. Since we are talking about the number of years, let it approximate it to 9 years. So therefore, after 9 years, the value of the machine, which was 23,240, reduces to 9,000. So 9,000 is called as the scrap value or the amount of depreciation. Next one, the scrap value obtained by selling a machine after 10 years of purchase is 19,660.8. If the machine depreciated at the rate of 20% per annum, find the cost at which the machine was purchased 10 years ago. So, n is given, that is 10. Scrap value is given, that is the final amount, 19,660.8. So, rate of interest is given, which is 0.20, which can also be written as 0.2. Now, I need to calculate the value of the cost price or the initial price. So, we need to calculate P. We'll use the formula A is equal to P into 1 minus I whole power n. So, 19,660.8 is equal to P into 1 minus 0.2 whole to the power 10. So, this can be written as P into 0.8 whole to the power 10. Now, P is equal to 19,660.8 whole divided by 0.8 whole to the power 10. So, dividing this term by 0.8 10 times. So, we will get the value of 1,83,232.05. So, this is in terms of rupees. That means the cost price or the initial value of the machine when it was purchased was in lakhs, but after 10 years, with the rate of depreciation 20%, the cost was reduced to 19,660. Next one, a factory owner wants to replace his old machine by another machine with new technology, which will cost him 75,000. So, he decides to sell his old machine, which he purchased 10 years back for 60,000. If the rate of depreciation is 10%, find how much more money he needs to buy the new machine. So, a factory owner wants to replace his old machine with the new machine whose cost is 75,000. The old machine was purchased for 60,000 10 years back. Now, we need to find the depreciation value of the old machine so that he will get some amount and how many remaining amount he needs to make to pay for the new machinery is what we need to calculate. First, let us find the depreciation amount of the old machine. So, therefore, here A is equal to P into 1 minus I whole power n. So, A is equal to 60,000 1 minus, so the rate of interest is 10%, so therefore 0.1 whole to the power 10. So, which is 60,000 into 0.9 whole to the power 10. So, therefore, the final value of the old machine will be equal to 20,920.70 in rupees. Now, he sells the old machine for the given amount here. So, how many more money he needs to buy a new machine? So, therefore, that is equal to 75,000 minus 20,920.70. So, that is equal to 54,079.30 in terms of rupees. So, that means the factory owner needs 54,079.30 rupees more to purchase the new machine, which cost 75,000. So, in this session, we have learnt the application of compound interest formula in varying interest, growth rate, as well as in calculating the depreciation value of an asset. I'll meet you in the next session. Until then, keep watching, keep learning, and keep exploring. Thank you.